Hey guys, welcome back to our channel. Today I just want to give a small introduction to binary trees. Now these binary trees are our today lead code problem, but before jumping onto the problem I just need to give a small introduction on this topic. So binary tree is represented with nodes and edges. So over here I've put how we represent the nodes and how we represent the edges. So it's very similar, but this is not like a it's a non-linear data structure. It's not like the data structure we used to see like arrays and linked lists. These are also data structures that do store your data, but they do not store it in a continuous format. They just store it in random places, and so they create a form of a path, so where you have one element as the root node. So this is the parent element, and this parent element has two other nodes, like it is connected to two other nodes. One is a B and C. Now the thing over here is that using this parent you can actually know your child. So using the root, you can traverse and know your child, and further you can have um, many more nodes as well. And there are many type of trees. So today we're going to talk about binary trees. So over here we say root as the top element. So whatever is at the top is what it is called a root element. And it can have at most 2 children per node. 2 children per node means you can have children, but only 0 children is allowed, 1 children is allowed, or 2, not more than 2. So a parent element cannot have like this, 3 child, or even if they have 2 childs, their childs cannot have 3 childs. So this is also not allowed. But they can have at most two children, so they can also have children. It's the reason they tell this as tree is because they look like trees. You can see this is the root, these are the branches, and these are called as intermediate nodes. Intermediate nodes, and these are called the ones that they can no longer further extend themselves. These are called as the leaf nodes. Right. And another important point you should know is that this is also a binary tree because you have at least one child. This is also a binary tree, just the root node is also a binary tree. Now, only a single path between the root and towards any node. How do we do that? For example, over here, let's say I need to go from A to let's name these nodes B, C, D, E, F, and G. All right. So let's travel from A to B and B to D. So to reach from A to D, you have one path, A, and then you travel through B and then to D. Now let's take another example. Let's say you want to reach from the root to the node C, and you have here one path. So A to C. All right. Let's take another example to check whether it's actually a binary tree or not. For example, we're gonna have a root node over here. Let's say A. And can you tell me whether this is a binary tree or not? This is actually a binary tree. See, they don't have any children, but we are allowed to have 0 children as well. So just a root node is considered to be a binary tree. Now we're going to talk about this node. the A, and we're gonna have one node, one child node, and this is also completely acceptable. Now let's talk about this node. A has a child B, and it also has a child C. Now let's make a path that you can also travel from B to C. So over here, this is acceptable, but it cannot be a binary tree because it does not satisfy all of the conditions that we mentioned here. We mentioned that we need only a single path between the root and towards any node. But over here, we have many paths to reach. For example, let's say you want to reach from the root to C. You can either traverse through A to B and B to C, or you can also go directly from A to C. So there is not a single path, there are multiple paths that you can do. So this is not a binary tree. Another thing is empty tree. So empty tree. An empty tree means that you don't have any root nodes, you don't have any data in it, you don't not even have anything. A node is created only when there is data. So when you do not have any data as well, this is considered as a binary tree. You do consider this as a binary tree. This one over here is also considered a binary tree because you can see over here we have two children of A as the parent, and A has two children B and C. B is the parent, B has two children D and F, and D and E, and C is the parent, and over here we have one child. Now I'm going to share with you guys how to implement that binary tree. So first, you do need to create a node class. So we're going to have a class node, okay? So this is our class node, and the class is which is going to contain the node details. Now, what does a node have? Whenever you pick up a node consists of a data. Okay, let's have it as a number 8. And the node can have a left child and a right child. Only two children, at most two children. Now, if this is also a node, and this is also nodes. Okay, this is also a node. So let's create for the data. We're gonna have a data, and we're gonna have the same data structure as node. We're gonna have left, and we're gonna have right. Now after this, I will be initializing this. Now you do need to initialize your binary tree. Yeah, I'm going to show you how to initialize it. You can simply use a constructor to initialize it, and you can simply pass a value. I'm going to pass a item. Let's have an item, and the data is going to collect the item, and left and right, both of them are going to be initially null. So this is the root node. So both of these are going to be initially null. Now this is for a root node. Now let's say you're gonna pass the left values as well as the right values as well. Okay, you're gonna pass the left values and right values as well. you do pass them as nodes. So you give node, you give left node, node, right node, and you have to left is equal to left node, and right is equal to right node. So if you want a very detailed video about these implementations, more implementations like insertion, inserting and then traversing, then make sure to leave them in the comment section below. Thanks for watching.